You can finish it, and then I'll run through roll. Yeah, remember, we did the sine of 2 theta. Well, I should say, we didn't do the sine of 2 theta, but we did the sine of a plus b, right? And what's 2 theta but theta plus theta? Get the idea? So first off, what's the sine of a plus b? It's the sine, cosine, cosine, sine. Remember that whole thing? Remember that? Let's go A, B, right? A, B, A, B. And sine is our friend, which means he keeps the same sign in the middle. Remember, cosine is not our friend. At least that's the way my friend used to memorize it in our junior college days before we transferred together to Poly. So, right, remember that? So sine is sine, cosine, cosine, sine. And remember, cosine of A plus B is cosine, cosine, sine, sine. So anyway, you can put them on your 3x5 card. And sine is our friend. He keeps the same sign in the middle. Okay, so what does that mean? Well, what if instead of A and B, you put theta and theta for both A and B? See, that's 2 theta, isn't it? Theta plus theta is 2 theta. Right? So I'm coming up with a formula. I'm coming up with a formula for sine 2 theta by just saying, hey, I'll just use the A plus B thing and let A and B both be theta. That's how I always handled math and science. I had a bad memory, still do, and so I would memorize one basic formula from which I could get all the other ones. So I would just memorize sine of A plus B, and then I would come up with the rest when I need to by just sticking in theta for both of those. So what's that going to be? Sine theta, sine theta. Right? If A and B are both theta, you with me? So in other words, the sine of 2 theta is going to be sine theta cos theta plus cos theta sine theta. Right? And the order of multiplying doesn't matter, right? Think about numbers. 2 times 3, is that any different than 3 times 2? No. 6 either way you do it. So in other words, writing cosine sine, you could just call this sine cosine. It's the same thing. It doesn't matter what order we put it in. So then what do we have? Sine cosine plus sine cosine. What's that?
2 times sine cosine.
Good. Think of them as big X's, because this and this are the same thing. So it's like X plus X. It's 2X. 2 sine cosine. You with me? It's just like terms, just invisible ones in the front being added, right? When we have the same 2 things added, you just add the numbers in the front, which are invisible ones. So there's the formula. The sine of 2 theta is 2 sine cosine. Just like that. Does that make sense? That's the formula we're going to use today in this section for that's the double angle formula for sine. We'll do one for cosine, and you know how we'll come up with it. We'll use the A plus B thing for that as well. So there it is. That makes sense? So how you do the sine of 2 theta is you take 2 times the sine of theta times the cos of theta. Now that we have that, can you, while I do roll, can you take this triangle, SOHCAHTOA, and find the sine of 2 theta? But how are you going to find it? You're going to take that triangle and find just the sine of theta on that triangle and the cosine of theta on that triangle and multiply a 2 in the front of those 2 answers, and that'll be your answer. Does that make sense? So I'm basically asking you, take this triangle and find the sine of theta, then find the cosine of theta, multiply those together and throw a 2 in front. And you've got the answer for sine 2 theta. All right, I'll finish in a second. Let me run through roll. So now that we have the formula, let me erase this stuff. And we'll just use the formula. So, okay. So, and you can just put the formula on your 3x5 card, you know. Just like this. Sine of 2 theta is 2 sine cosine. So remember in SOHCAHTOA. And what's the sine? So we want the sine of just regular theta. So keep straight. Sometimes we're doing the sine of 2 theta. Sometimes we're doing the sine of regular theta, right? This says the sine of 2 times any angle. If you plug into the toaster, double angle, what it'll equal is a 2 in front of the sine of the regular angle times the cosine of the regular angle. That's what that's saying, right? So what's the sine of the regular angle? Well, sine is opposite over hypotenuse. This is the regular angle. That's not a 2 theta. That's a regular theta there, huh? So the sine of the regular theta is, this is opposite adjacent, hypotenuse. Opposite over hypotenuse, so it's 12 over 20. And then we can reduce that, divide by, what, 4? Top and bottom be 3/5. That's the sine of theta. Cosine of theta is adjacent over hypotenuse, so that's 16 over 20. Divide by 4, top and bottom, 4/5. So, putting it all together then, what's the sine of 2 theta? It's going to be 2 times the sine of theta, 3/5, times the cosine of theta, 4/5. We good with that? That makes sense. Put this over 1. Multiply those together. 2 times 3 is 6, times 4 is 24. On the bottom, 5 times 5, 25. So we got it. 24 25ths? How many got that? How did you do on that? Good. Chunk of you got that, like half of you. Questions I can answer on that one? All is well? All right. Good. Questions I can answer on that one? Other questions on that one? That good? All is well there? Okay, I'll move on. So let's try this one. Okay, so here we have the sine, cosine of 2 alpha. 2 alpha, 2 theta, don't worry about it, just 2 whatever. You can call that 2x if you want. So the sine of double the angle. So I'm sorry, cosine of double the angle. So let's figure out the formula first off. What is the cosine? You know what I'm going to do? I'm going to say, look, just go back to the cosine of a plus b. Right? And then just figure it out. And then we're going to call them both theta or both alpha, whatever you want, whatever letter you like. So what's the formula for the cosine? We did that last time, right? That was the last section, last night's homework. Yeah, cosine, cosine, sine, sine. And as my old buddy used to say, cosine is not your friend. He does the opposite sign in the middle. So the plus sign becomes minus, the minus becomes plus, right? And then you do AB, AB. So that's the formula we did last time.
Is it just a plus b by default because we're not given like you know how it says if it's cosine a minus b, we'll switch it to
Right.
But because it's not given here, we just assume
Well, no, the reason it's not because it's not given. It's because of the fact that I'm trying to find the cosine of 2 times alpha. That's what they're asking me for. So that would be 2 alphas added, not 2 alphas subtracted. Good question. Everybody track with me? Everybody see why I'm using the plus formula? It's a good question, good comment. It's because they're asking me to find the cosine of double alpha. So that means alpha plus alpha, doesn't it? So I got to use the plus formula. So, all right. So now I'm coming back and I'm going to say, all right, just basically let both these guys be alpha. Right? Just use the A plus B formula, but let them both be alpha. Alpha plus alpha, that is 2 alpha. You'll have the formula for 2 alpha. Right? In other words, the formulas we got in the last section, last time, the adding and the subtracting, sine of A plus B, cosine A plus B, those are more generally useful formulas. Whereas these guys are more particular, right? You see what I mean? I could do any 2 angles added with that cosine A plus B. So they're asking me to add exactly the same. That's what 2 alpha means. Alpha plus alpha exactly. Right? See how this one's more general? They don't have to be the same 2 angles. A and B don't have to be the same 2. This is the formula for adding any 2 angles. So in particular, I could add the same angle twice, alpha and alpha. Right? Let that be alpha, let that be alpha, let that be alpha, let that be alpha. What are you going to get? Cosine alpha, minus sine alpha. Right? So the cosine of 2 alpha must be this. And can I simplify that? That's cosine squared alpha minus sine squared alpha, isn't it? Now let me give it to you the way the book gives it to you. So I think they're going to take one more step. I want to make sure before I give it to you so I don't confuse you. Yeah, well, they show both ways. I will too. Yeah, so what you could, now that's fine. You can use that formula. That's well and good and great and fine. But what's even easier, what will be even more helpful to you, is you can make a nice little substitution here. You could say, okay, look, what is cosine squared? Good memory, Chanu, I'm impressed. Yes, Remember that sine squared? Remember, it's the big one. It'd be good just to know that one cold, because it's just like all the time in trig they use that one. Sine squared plus cosine squared equals 1. Remember that one? So you can, remember, at any time you can solve that basic one, sine squared plus cosine squared is 1, for either one, sine squared or cosine squared. So I could say, look, I want solve for cosine squared, so I'm going to jump this to the other side. So cosine squared is 1 minus sine squared, right? Everybody see that? Cosine squared. So anytime you want, you can replace cosine squared with 1 minus sine squared, because cosine squared is the same as 1 minus sine squared, right? So right there, I could say, look, that cosine squared is 1 minus sine squared of alpha. And then at the back, I still have the other sine squared alpha. Now, why would I want to do that? Well, because that way I don't have to do sine and cosine. I've got it all in terms of sine now. And what is, let's finish it up, one more step. What is minus sine squared alpha minus another sine squared alpha? Remember, invisible ones in the front when you're adding like terms. So it is 1 minus 2 sine squared alpha, isn't it? That's the easiest formula to use. Now, what am I losing you? Am I making any sense? What I'm saying, let me write it really clear. What I'm saying is that when you're being asked to find the cosine of 2 alpha, you could use this one here. This is true. You could use cosine squared alpha minus sine squared alpha. Or, what will be probably easier, is 1 minus 2 sine squared alpha. Either one of those. They're both true. They'll both work. But this one, you only have to find one trig. Only have to find sine. You don't find sine and cosine. Wendy.
Could you replace sine with cosine?
And you could do it the other way too. Both ways work. That's right. So yeah, so I could have replaced the sine squared here with 1 minus cosine squared. You can always do that. You guys getting the hang of that? They're going to be doing that a lot. They'll have sine squared, and all of a sudden there'll be this 1 minus cosine squared. Or they'll have cosine squared, and all of a sudden they'll pop in a 1 minus sine squared. In the next section, before the weekend, I was getting ready. The next section is like probably the hardest in the book. So come sharp. And in fact, I wouldn't want to start it today, because this is the easy section compared to the next. I'm breaking the next into 2. I don't know if you noticed the homework. I made it a part. It's so hard, I thought we need 2 whole days on it. Part 1, part 2. I remember it is the hardest thing for me when I took trig. It's trig equations. Anyway, my point in that is like things like this, you need to know. They're going to whip them in and whip them out, and you need to be thinking of it and have it on the tip of your mind. So cosine squared, anytime you see it, you can replace it with 1 minus sine squared, or vice versa. Sine squared, 1 minus cosine squared. So yeah, all right, so either one of those formulas will work. Yeah, I could say, yeah, or I could give you, if you replaced, maybe I should do the other version. If you replace this guy here, the sine squared, with 1 minus cosine squared. But remember, there's a minus in the front, this minus in the front, so that'll distribute. And you'll get cosine squared plus cosine squared, so that'd be 2 cosine squared minus 1. That one's also true. That's what Wendy was talking about. You could replace either way. So we have 3 versions. Use whatever's easiest at the moment in the particular problem you're working on. Is this making sense? So what I'm saying is, let me erase this work and we'll actually finish the problem now. That was all derivation, coming up with the formula. We won't do that again. I won't mess with that every time. Once we have it, now we'll just crank it, right? From now on. So I'm saying when you have cosine of double angle, you could use 1 minus 2 sine squared, or you could use 2 cosine squared minus 1 of the regular angle. See how these are both just regular alpha. Regular alpha. See how we're changing double alpha into regular alpha with these formulas? Because we can't do double alpha. There's not a double alpha in the triangle. We have to have a formula that'll turn it into regular alpha. I'm saying a lot of words. Am I reaching you? Is that making sense? All right. So here we go. They're saying cosine of double alpha. So how am I going to do it? Well, how about I just use this one? It's 2 cosine squared of regular alpha minus 1. Okay, so I need to look at this triangle here and find the cosine of regular. Here's regular alpha. So what's the cosine? Well, SOHCAHTOA. SOHCAHTOA, what's cosine? Adjacent over hypotenuse. This is the adjacent side. This is the opposite side. I need the hypotenuse. Pythagorean Theorem. Also, do you just recognize that one?
3, 4, 5.
It's a 3, 4, 5 doubled. Do you see that? They do that all the time. Remember I said it'll really help you if you just remember 3, 4, 5 and 5, 12, 13. They take those three all the time and they'll double them or do something like that. Half of your triangle Pythagorean problems will be those two multiplied by 2 or 3 or 1. You with me? So look, double 3, 4, 5, what do you get? 6, 8, 10. That's what this is. See the 6, see the 8? This is going to be 10. I'll show the formalities, but if you recognize that, you can save some work. It's going to be 10. It's 3, 4, 5 doubled. You see that? So no, 3, 4, 5, 5, 12, 13. They use those two all the time. It's how they who write these trig books do it. All right, anyway, I'll show you the formalities, though. So it's the a squared. So over here, the triangle. A squared plus b squared is c squared. So 6 squared plus 8 squared is c squared. We're looking for the c, which we know is 10, really. 36 plus 64 is c squared. 100 is c squared. Root it. Root it. There it is. Sure enough, c is 10, like we knew. So it's 10. All right. So what's the cosine, then, of regular alpha? Excuse me. Adjacent over hypotenuse? 8 over 10. Oh, squared, huh? Almost forgot the square. You with me? So 2 times the cosine of alpha, 8/10, squared, minus 1. That's the cosine of double alpha. So let's figure that out. Square this, it'd be 64 over 100, minus 1. Okay. So then let's simplify that. Coming up here. Now, how do you do? It's all, I know it's all this little stuff. A lot of times, most of the time when I'm working with students, it's all the little stuff. They get the big stuff. They get the formulas, the plug, and all that. But it's all this little silly stuff. So let me make sure I'm helpful with that. What do you do when like a whole number is multiplying a fraction? It's over 1. You remember that? You comfortable with that? So that 2 just goes to the top only, huh? So it becomes 2 times 64, 128 over 100. Minus 1. We good like that? Or you could have cross-canceled, too. Anyway, I could just reduce now. So divide by, I don't know what, maybe 4. Top and bottom, what is that? 6, 4, 32. 32 25ths, minus 1. And like right here. A lot of people get right here and they'll be like, what do you do with that? It's all that little silly stuff. How do you subtract 32 25ths minus 1? How do you subtract two things? You make that 1 into? 25 25ths. That's a fancy 1, and now I can subtract them, huh? You with me? You guys catching that? It's that little stuff that gets people. So I want to be helpful to that, right? So if you have like a 1, you got to make it into, you got to have common denominator to subtract two fractions. Oh, that you know?
Yeah. We don't reduce to 8/10 or
8/10.
can we?
Oh, we could have. That probably would have been a good idea, just to make that 4/5 right away before I squared it. Either way. But I think your way would have been better. That would have been a little cleaner. Yeah, probably would have been a better idea to make that 4/5 first, then square it. Then I wouldn't have had so much reduction to do later. But it'll work either way, as long as you eventually reduce it. Good point. Subtract these now. What do you got? 7 25ths. And, you know, your calculators will do a lot of that. Do you guys know that, if I showed you that? Right? Calculators will do a lot of that just automatically. Reduce the fractions, all that kind of stuff, right? You guys know how to do the fractions on your calculator? I showed that, right? Didn't I do that one time?
I think you did.
Yeah. That good? All right. Feel free to grab me 5 minutes after class. Well, calculator stuff. 10 seconds. Be able to get you going. Questions on that one? Is that good? So I was saying for cosine of double alpha, you can use any of these 3 formulas. Really, this one also. Any of those 3 formulas. These 2 are going to be the most useful. And it'll work. So what's this section about? What are we doing here today? We're saying, how do you handle double angles? Like 2 alpha. That's what, double, it's the name of the section. Double angles, and we're going to do half angles in a minute. How do you handle double angles? Well, we got a formula now for sine of double alpha, and we have a formula for cosine of double alpha. You use those. Okay, so use the given information to find the exact value of a sine 2 theta. And of a, I kept thinking there's wanting me to find a. That's part A. Okay. Sine 2 theta, cosine. Okay, so sine 2 theta. Okay, so let's give it a go. So first off, I would just write down the formula, which you'll have on your 3x5 card. A lot of formulas for this next exam. You'll have on your 3x5 card. Sine 2 theta is 2 sine of regular theta cosine regular theta. Good? You'll have that right in your card. Just automatically, you see sine 2 theta, you go, oh, it's 2 sine regular theta cosine regular theta. Oh, by the way, we're looking for, today's the 9th. Next week, we're scheduled for our practice exam on Monday and our real exam on Wednesday. I'm pushing all that back one meeting. We need an extra day for that 3.5. So let me be clear. Practice exam next Wednesday, practice exam number 3, next Wednesday the 18th, October 18th, and real, so you don't have a real exam next week. It's 2 weeks from today. Real exam is Monday, 2 weeks from today, 10/23. So basically I'm taking your schedule and pushing everything back one meeting. We'll probably be back a meeting for quite a while in the schedule, and we'll eventually catch up because I'm going to skip 5/5, but that's the second to last week of the course, so that's where we'll catch up. So, all right, so there's the plan. So next Wednesday is a practice exam, and 2 weeks from today is the real exam. So you see sine 2 theta, you write that formula, and you go, okay, to find sine double angle, I need sine of regular angle, cosine regular angle. Multiply them together and throw a 2 in front. So how do I get that? Well, here's cosine regular theta. They're handing me that on a silver platter. Don't got to do any work for that. But what about this? I also need the sine of regular theta. Triangle time. They are not going to stop making us do this, which is really actually it's painful, but they do it in calc. So if you're moving the way of pre-calc and calc, this is great practice because you got to do it a lot. All right, so let's do it. So again, I would just make a triangle in the first quadrant. The fact that they say quadrant 4, the only difference with the various quadrants is the signs, plus and minus, right? So I can handle that with all students take calculus. You with me? Let's just do that part right now. All students take calculus. So if you're in the 4th quadrant, that means only cosine is positive, and his reciprocal, secant. The other 4 trig functions are negative. So what am I looking for? Sine. So sine is negative in that quadrant. So I know sine's negative in the 4th. I'm trying to find sine in the 4th. It's got to be negative. So I'll do that later. I'm just going to make my triangle in the first quadrant because it's easier to work in the first quadrant. So here we go. Little right triangle. Put your theta right there. Remember what we do? We just make a triangle. What kind of a triangle? A triangle that reflects this truth, that the cosine equals 16/34. What's cosine? Remember SOHCAHTOA. Cosine's adjacent over hypotenuse. So this is adjacent over hypotenuse. So here's theta. Here's my little thing. This is the opposite side. This is the adjacent side. This is the hypotenuse side. Right? Let me get rid of the all students take calculus thing. This is the adjacent. So anyway, what is it? Opposite, adjacent is 16, so this side is 16. Hypotenuse is 34. So I need to find the opposite side with the Pythagorean theorem. So here we go. So I'm going to say whatever the opposite side squared plus 16 squared is 34. So that looks weird to call it O, so I'm going to call it X. Call this X. X squared plus 16 squared is 34 squared. Y'all with me? Pythagorean. So that's X squared is some big number. 256. And I don't know what 34 squared is. I got it?
1,156.
1156?
Yeah.
All right. Just do that off the top of your head?
No,
Oh. I was impressed.
I'm not that measured.
256, subtract it. X squared, is that like 900?
Yes.
That's nice. Root it. X is 30. Beautiful. X is 30. So that means this side over here is 30. Did my little Pythagorean work? That side is 30. So what? So what's the sign then? The sign, remember, is opposite over hypotenuse. Opposite over hypotenuse. 30 over 34. 2 in the front. Cosine theta they gave me from the beginning. 16 over 34. Now I just need to reduce those fractions. Is that good? Everybody see how I got to there? Can you reduce all that? Finish that up from there. Use your calculator. Maybe some of your calculators will just do it automatically, which is great. Just do that if that works for you. If not, just do it by hand. Remember that 2 is 2 over 1. Reduce the fractions. Multiply them. Reduce them. And get a final answer. So if you can make sure you can do these little nitty-gritty details. These can trick people. All right, so 2 over 1, and you could just multiply, I don't know what. It would be easier to cross-cancel. Can I do that? I'll go 2 into 34 17 times. I'm going to reduce this. Divide them both by 2 leaves 8 and 17. Yeah, that's better. Now multiply 30 times 8, 240. 17 times 17, I have no idea. 289?
Yeah.
There it is. It came back from the far reaches. So there it is. I did a little reduction. You can do it a million different ways. I reduced. I went 2 into 34 17 times. And I divided both these by 2. And then I multiplied the leftovers. But there's a million ways to do that. 240 over 289. There we go.
Isn't there a negative though?
Oh, thanks. Negative. I forgot about that negative, right? Because we're in the fourth quadrant. All students take calculus. So only cosine is positive in this quadrant, but sine is negative. So this should have been a negative 30 34ths. The sine should have been negative right here. Whoops, that's a big negative sign. Should have been negative 30 34ths. Thank you, Wendy. And so, yeah, so that's a negative answer. Because one of the items is negative. One negative sign, the answer is negative. Thank you. Good? On that now, it's better? Questions I can answer? All right, I'm going to... So that's part A. They wanted the sine of 2 theta. Yeah, the rest will be easy. Whoops, I shouldn't erase the triangle. Because I'll need him. Will I? No, I won't need him. Let's erase that triangle. Okay, so part B... So there's part A. Let's put a line there. Now part B, that's all part A. Part B, they say, hey, find the cosine of 2 theta. Now I gave you a couple different formulas, right? I gave you, what was it? 1 minus 2 sine squared of the angle. Or 2 cosine squared of the angle minus 1, right? I gave you both formulas. You can use either one. I'm going to use this one because they gave me cosine from the beginning. Cosine of the regular angle, right? From the beginning, I had cosine of the regular angle. So this formula says cosine of the double angle is 2 cosine squared minus 1 of the regular angle. What's cosine of the regular angle? 16 34ths. Just plug that right in. How easy. Don't need to mess with triangles or anything. Is that good there? Everybody tracking with me? Now that's going to be some big numbers. Use your calculator. Again, it's 256 and 34 squared. Wendy told me, but I forgot. It's something. It's off the screen now. It's 11:56. Thank you. Minus 1. Good. Again, your calculator might just handle it straight. I'll do it by hand. So 2 goes into 1156. I don't know. 578? Is that right? Nobody knows. 1,000. Let's see. Is that 140? Yeah, well, that's right. Okay, so I did that. So I've got 256 or 578 minus 1. This is all the painful part here. Then reduce that thing. I don't know if you can even see that. So I'm going to reduce it. Let me bring it over here. 256. 570 minus 1. I'm going to divide top and bottom by 2. Divided by 2, it's 128. Divided by 2, it's 250 and 39. 250 and 39. 289. So 128 over 289 minus 1. What do you do with that 1? So I reduced the fraction as much as I could by hand. And then what do you do with the 1 always? Yeah, make it 289 over 289. A big fancy 1. You can subtract, it's going to be negative, isn't it? Negative 161 over 289. There it is. So your calculator can do that automatically, probably. Come up and grab me after class if you want me to show you how to do that on your calculator. Just take 10 seconds of your time. All right, that's part B. Finally, there is a part C. Let me do it up here. B easy as well. Part C, they say, give me the tangent. Now, I have not given you a formula for tangent 2 theta. I could, but we don't need it right now. If you want the tangent of double angle, what could you do? Sine of double, but it's got to be the same angle, huh? Sine of double angle over cosine double angle. Y'all tracking with me? If you want tangent of double angle, you got to take sine of double angle over cosine double angle, right? So, what's sine of double angle? We found it right here. Minus 240 over 289 over, and what's the cosine of double angle? This one. Minus 161 over 289. Right? And then you know what to do from there. When you got a fraction on the bottom, you flip it up. So minus 240 over 289 times, flip it up. Here we go. 289 over 161. So the 289s cancel. The two negatives cancel. 240 over 161. Positive. 240 over 161. I don't think that reduces. I could be wrong, but probably not. Did you track with me on that? Everybody see what I did? I found the tangent of double angle by just saying, well, look, it'll just be sine of double angle over cosine double angle. So remember, the angles that when you do any formula, the angles need to match, don't they? 2 theta here, it's got to be 2 theta in those places. Right? So, and then I just used the formula, just this over this, and flipped up the denominator. Cross cancel. There we go. So it's good. Once you have a sine and cosine, the tangent's a snap, isn't it? Part C is easy. All right, let's see. So they're giving me this. Now that looks like the cosine of 2 theta, doesn't it? Doesn't that look like the cosine 2 theta formula? That's what I'm thinking. I'll just tell you the way my mind's working because I don't have the whole answer right now. I really don't. I'm just thinking it out here with you. I just look at that and I go, okay, that looks like cosine 2 theta formula to me, which is cosine squared of theta minus sine. That was one of the 3 versions I gave you. If you look back, yeah, here, we can look back. Look back, wait, where was it? Remember, cosine of a double is cosine squared minus sine squared. See, that was the first version I gave you. Then I gave you these other 2 also. Right, we had 3 versions of the cosine double angle formula, right? So as soon as I see that cosine squared minus sine squared, I'm thinking, okay, that's cosine of double the angle. Okay, so what? Well, that means if the angle, the theta, is 150, if this is 150, 150 degrees, 150 degrees, then, you know, if that's what theta is, that's what theta is. So it's 150 degrees here as well. So double that, that's cosine 300 degrees, isn't it? You with me? So this has got to be a formula for cosine double that, 300. So I can answer this question at least, right? Cosine squared 150 minus sine squared 150 is cosine 300.
That's right.
Double that, right? Double the 150. Okay, now the other two are what baffling me a little bit. How am I going to do the other two? It says which. Oh, okay. You can't. I see. No wonder. Yeah. No, this is the answer, and we are done.
There's a
Yeah.
second part. It says.
Is there?
The exact value.
Okay, we'll get it. We'll do that too. Yeah. No wonder I was confused though. You can't get the other two for now. It's multiple choice. I thought that was like part A, part B, part C. It was multiple choice. That's what I didn't realize. I didn't read this part. Select the correct choice below, and fill in the answer. It's this one. Everybody good with that? Okay. Yeah. Now let's do the part 2. So now they want to know, what is that answer? Well, I don't know. Let's figure it out. So what is the cosine of 300? You can just use your let's assume, because any of this stuff could be on the part 1 with the no calculator. So let's find through. Where's 300 degrees? Can you do that? Let me give you a second. Maybe it'd be better if you did it by hand. Can you find the cosine 300? All I'm doing now is just this. Forget about everything else in all the problem. Who cares about anything else? Just cosine 300. Can you do that? Give it a try. Use the unit circle. Find where 300 degrees is. You know, no calculator. This could be on part 1. Find where 300 degrees is. And then draw a little triangle. Do the small, medium, large thing. This really needs to become comfortable for you at this point. Be able to do the small, medium, large, find the angle. So we're doing more and more and more of that. That won't go away. So this is 270, this is 180, this is 90, this is 360, right? So where's 300? Well, it's just 30 degrees off of straight down, huh? It's right there. Isn't that good? So what does that mean? That's over a small amount, down a large. This is small. So remember the small, medium, large. 1, 2, root 1, root 2, root 3, all over 2. That's the small, medium, large. 1, 2, 3, over 2. Right? So this is small. I didn't do small. Good thing I wrote that out. Small and large. Yeah, it's the 1 and the 3. That's the small and the large, not the 2. The 2 is the medium. You guys need to keep up. All right. All right, thanks for your patience. All right, so small over small, down large. So there it is. And cosine is x, sine is always y, right? Cosine's always over, sine's always up and down. So, and technically the sign is negative, it is down, and this is positive, right? But you could also figure that out from the all-student state calculus. Either way. So what do they want from me? Cosine. Cosine is plus a half, isn't it? And that's also because of all students take calculus. Cosine is positive in that 4th quadrant. So sure enough, positive half. There it is. Good? Can you all do that by hand? If not, come see me. It'd probably take you half an hour with me. All right, here's the tangent formula, everybody. I've been holding out on it. It's tangent of 2 times any angle is 2 tangent squared of the regular angle, right? Remember, we're always getting double angle formulas in terms of regular angle, over 1 minus tangent squared of regular theta. Is that good? So there it is. I'm not going to derive it or mess with it. I mean, if you're interested, come see me upstairs. I'm just going to use it. So there it is. There's the tan. So now we have sine of double angle, cosine double angle, and tangent of double angle. You can put them all on your 3x5 card. This might be a crowded 3x5 card for this exam. We've had a lot of formulas because we had all those A plus B formulas last time. So, all right. Anyway, there it is. So looking at this, you see how this is what they're doing here? It's a version of that. Right? Okay. So what is it? It's, well, what's the theta? What's the theta right here? Well, theta is pi over 2. Right? They're plugging in pi over 2 here. Oh, not supposed to be squared in the top. I'm sorry, guys. Remove that squared. That's not there. It's not. It's 2 regular tangent on the top over 1 minus tangent squared on the bottom. So, all right. So the theta is pi over 2 in both cases. So this is the so therefore the theta is pi over 2. Right? If the theta is pi over 2 on the right side, it's pi over 2 on the left side. So therefore this becomes the tangent of 2 times pi over 2, better known as the tangent of pi, because these guys cancel. That's tangent of pi. This option, tangent pi, we're done. Did you track with that? So I just looked on the right side, I compared this to that, and I said, oh, they're putting in pi over 2 for theta. So theta, anywhere I see it, is pi over 2. So right over here, I said it's pi over 2 there also. It's pi over 2, then I just 2 over 1, just canceled, tangent pi. This is a big fancy tangent pi. What is the tangent of pi? Who can get it first off the top of your head? We should have competition. I wish we had time to do that. We could have a tournament. How fast can you do the trig functions, the small, medium, large? 0. Good job. Is that off the top of your head? Way to go, Rudy. How do you know tangent of pi is 0?
Because 0 pi is 180.
Pi is 180.
Tangent sine over cosine.
Pi is right here at 180. Tangent is sine over cosine, exactly. So tangent of pi is sine pi over cosine pi, which is right here in the unit circle. And
Sine over, yeah, so the sine is 1.
sine is 0. So we need no more information. 0 over who cares
I just
is
knew
0.
it was 0, so I just...
Exactly, right? Sine is 0 there. The height. Sine is height. What's the height of that dot? 0. 0 over anything is 0. So the tangent of pi is 0. So they're not asking me for that, but if they did, tangent of pi would be 0. All right. All right, so I'm not gonna derive these. We just don't have time for everything. Come see me if you want to see where it comes from. So the sine, here it is. So the sine of any angle divided by 2. So the first 6 questions were all the double angle formulas. Sine of twice an angle, sine of 2 theta or cosine 2 theta or tangent 2 theta. Now we're going to get the sine, cosine, and tangent of half an angle. Here it is. It's plus or minus the square root of 1 minus the cosine of theta over 2. There's the sine one. So notice again that the right side is regular theta, isn't it? The left side is half of theta, theta over 2. The left side is, this is half an angle, but this is regular. So we're always getting the formula in terms of regular theta. Okay, so here we go. How can I do the sine of 15 degrees? They want me to give an exact answer for that. Calculator can't do this one. Like, not at all. Even if you had a calculator. You guys have your calculator? Type it in. Sine of 15. It's just going to give you some decimal, which they...
Mine actually does it.
Does it? I'm so impressed.
Mine does it too.
Wow. Is that the Casio Natural Display?
Yeah,
Man, those things are good. Back in my day, they never did it. When we were in the covered wagons. All right, so sine 15. So I guess the calculators will do it. But anyway, we'll have to do it on part 1 without the calculator. So how am I going to do, like, what am I supposed to do with 15? You know, because we don't know 15, right? When you think about our memories, you know, whenever they ask us to do one by hand, you know, part 1 of the test, or what they're asking here, they mean using your memorized values, your small, medium, large, right? Well, 15 is not one of my spots, right? What are my spots on the unit circle? It's 30, 45, 60, right? Or 90, of course, you know, or 0. But, you know, not 15. 15's not one of the ones we memorized. 30, 45, 60. How can they ask me 15? How can they ask me 15? In terms of a half angle. What's it half of? Well, it's half of 30. They want you to use the half angle formula for 30. Because that's what 15 is, 30 over 2. So you take the half angle formula and you let the theta be 30 degrees. You let that theta be 30. So over here, you plug in for the theta 30 degrees. It's going to be plus or minus, I'll explain the plus or minus in a minute, 1 minus cosine 30 degrees over 2. You tracking with me? So when you look at 15, you say, oh, that's 30 divided by 2. That's the half angle formula of 30. That's half of 30.
But what do we see? Oh, yeah.
I'll show you the plus or minus. Yeah, just a second. So is everybody good to there? That basic idea of what I'm doing? I'm looking at 15 and going, oh, that's half of 30. They want me to do half of 30. So theta's 30 over here. So I got to figure this out. Now, what is the cosine of 30? That I can find. Here's my 30 degree, right? Over and up. So it's over a large amount, root 3 over 2, up a small amount, up a half. I'm just going to, yeah. And cosine is x. So cosine's root 3 over 2. So it is plus or minus square root of 1 minus cosine. Root 3 over 2, all over 2. Good so far? Now, what's with the plus or minus thing? Well, what they're saying is, make it plus or make it minus depending on what quadrant you're in. All students take calculus. Just figure that out yourself. They're saying it can go either way. The sign can go either way depending on what quadrant you're in. What do we mean, what quadrant? Well, what's my actual angle? What's the left side? Sine 15 degrees. That's the real question. 15 degrees is in which quadrant? 15 degrees is in the first quadrant. So they're all positive in the first quadrant. So we'll go with the positive option. Now, yeah, we'll see another one where we have to worry about sine more, and I'll explain more at that time. Let's just move ahead. This one's positive because it's sine of 15 degrees, first quadrant, so positive. Now, how do I simplify this big mess? Because that is a big mess. So this is, I can't leave, that's called a complex fraction. You can't leave it. You can't leave, let me make it a little neater here. Fractions over, so that's fractions over fractions. You can't leave fractions over fractions. Oh, no, I can't square it. You mean to get rid of the root? No, you can't. You can only, if you do, remember, one thing to really remember, anything you do, you must do it with balance. So if I was to square it, I'd have to also square the left side of an equal sign. I don't want sine squared over here. Does that make sense? So whatever you do, you must do it with balance. So first thing is I'm not worried about the root right now. In fact, I'm not going to do anything with the root. I got to get rid of this 2 here because I don't want fractions over fractions. So what you do is you multiply by 2, but not just that. If I just did that, that would not be balanced. That's only the top. You have to also do the bottom. That way you're not changing anything, right? If you do the same thing top and bottom, it'll only look different but not be different. It's okay. It hasn't changed, right? Whenever you bring something new, so you want to be really clear on that fundamental concept in math. Whenever you bring something brand spanking new that wasn't already there, you do it with balance. 2 ways to balance: top and bottom of a fraction or left and right of an equal sign. Always balance, so we don't change things. All right, so what happens here? These cancel. That's why I did it. That's 2 over 1. It cross cancels right there. The other places it just multiplies. 2 times 1 is just 2 minus root 3 over 4. There's my answer. Why is that better? That's just a normal fraction. That's not fractions over fractions, what we call a complex fraction. Normal fractions are fine. It's kind of weird, huh, having a root in a root? But that's what your Casio showed you, right? Casios never lie. There it is.
Was that fancy? That's what I got.
Oh, did it show it different?
I think it actually roots it.
Interesting. Root the top, root the bottom. Oh yeah, we should root that bottom, huh? Yeah, let me look at this for a minute. See, yeah, it's interesting. Let's see. This answer is actually not okay, I'm realizing, because that's a root 4 in the bottom. We need to make that 2. Everything else is fine. But the root 2 we need to make that a plain 2 in the bottom. So let's do that. Let me bring it up here and do one more step of simplification. So, right, you see what I'm saying? This is a root 4 in the bottom, isn't it? So whenever you have a root over an entire fraction like that, you need to put the root on the top separately and the bottom separately. Before down there, 2 minus. Still got double root on the top, and that's fine. The bottom, root 4 is 2. That's a fine answer. Let's go type that in, but I'm still interested in why it shows a different one, and I'll figure that out in a minute, but let's go type that in for some. So that is the answer. Everybody see what I did in that last step? Just the root over the entire fraction. I put that over root onto the top and the bottom root 4 is just 2. Now, I'm interested, maybe for you, those of you that have a Casio.
Yeah, I got like that. I got a weird decimal number too.
Decimal?
Yeah, like when I did like the sign of my number.
Yeah.
I had sign of
I'm getting roots. I mean, you're showing me root 6 minus root 2 over 4.
And it's in degrees, right?
Well, I think so. I think that's the right answer. So, yeah, what's up with that? How could that be the real answer? I don't know. Let's figure it out. Is that what you guys are getting? Let's see, what mode are you in? Yeah, you're in degree mode. Yeah. So that's, how is this answer the same as that answer? Are they the same? I think they must be. I can't see it right now. Let me think for a minute. What could we do? Are you guys interested in me showing you whether they're the same? You don't have to do it on the test or anything, but I'm interested. Hope you're interested. Let's spend a minute on it. What would I do to see if those are the same? I don't know. They're just different forms, aren't they? Boy, nothing comes immediately to mind. What I could do, I guess, no, that won't work either. I do not know. I do not know why those would be the same. I could take the other one. So I'm going to try stuff. I don't know if this is interesting to you at all, but I'm going to go quick. Not required. Again, not required. Both answers are fine, I'm sure. But let me take this one. Does somebody have a... What's the decimal? I'm going to make sure they're the same before I go further. I'm getting, for this one, it's telling me 0.2588, blah, 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 blah. What about the other one?
it's the same.
It is the same. Good, thank you. So let me prove it. We proved it by decimal, but let me prove it by algebraic steps. I'm kind of interested if I even can. Let's try. All right, so multiply. I'm going to just try stuff, guys. I don't know what's going to work, but I'm going to fiddle around. Anything I do, I'm going to do with balance. You don't have to write this down. You can just watch and be entertained or whatever you want. I'm going to multiply top and bottom. I'm just trying stuff that's legal, right? Same thing, top and bottom. Anyway, I'm just going to go kind of quick because I don't know where I'm going. 6, that'll cancel out. That'll be minus 2. The bottom will be 4, so it'll cancel out that other 4. So if I get it and it's right, then I'll slow down and show you what I did. 4 should cancel. It'd be 1 over root 6 plus root 2. That's the same thing as that. And then I could, that didn't really get me anywhere. So that's the same as that. I get that outer root. I got to do something about that outer root. Maybe I'll fiddle with this one. So if I take that outer root thing and I multiply by what? I don't know. That old outer root thing? What will that do? It'll cancel that out and you get 2 minus root 3 on the top and 2 minus the root of 2 minus root 3 on the bottom. That's just ugly. That's just not going anywhere nice at all. Well, I don't want to use it any more class time. It doesn't come in quickly to me. Yeah, that's it. I'm going to think about that later. All right, no more. Okay. Let's try this one. So, I need to give you double angle, half angle formula. So, tangent of theta. So here comes the half angle formula for tangent. It's what is it? They give me some weird versions here. So it is, I'm going to give you 3 versions. Plus or minus the square root of 1 minus cos theta over 1 plus the cos theta, which equals 1 minus the cos theta over the sine theta, which also equals sine theta over 1 plus cos theta. So you can use any of the three. This one, right? Is that making sense? You can use this one, or you can use this one, or you can use that one. They're all right. They're all good. Okay. So when you look at tangent 165, what do you think? Good job. Yeah, because when you're doing the half angle, they're telling me right here, half angle, that's where I'll say it on the test, half angle, that means you need to think double this, because this is half of something bigger. Didn't say that very well. You know what I mean, right? You need to look and say, 165 is the half angle. It's half of what? Well, whatever times 2. Times 2 is at 330? Yeah, so basically this is tangent of 330 over 2. So I mean that is 165. It's half of 330. So whenever they tell you to use the half angle formula, you have to use half of the angle twice as big. Make sense? So guys and gals, I think it'd be easiest to just use this one right here. How about we just use that? 1 minus cos of what angle? What angle am I going to put in there? Yeah, 330 over sine 330. Does that make sense how that works? So whenever you have an angle over 2, you do 1 minus the cosine of that angle over sine of that angle. Yeah.
How is in the second formula it's 1 minus cosine, and in the third one it's 1 plus cosine?
Yeah, and well, I didn't derive it. I'm not sure how they came about with it, but notice it's 1 minus cosine in the top over sine in the bottom. And this is 1 minus plus cosine in the bottom, sine in the top. I don't know. I didn't go through the steps. But those are different. Some similarities, but different. So I'm sure it's true that those are really equal. Those are different versions. You can use any of those three, is what I'm saying. You'll get the right answer with any of those three formulas. They're all the same thing. All right, so let's do what is the cosine of 330? And what is the sine? So go ahead, let you do the unit circle thing. So do the unit circle, find 330 degrees, small, medium, large, and find the cosine and the sine. I'm going to erase the formulas and do the unit circle up here. So 330 is right here, almost to 360, huh? It's just 30 degrees away from the 360. And that means it's over a large amount, down a small, isn't it? It's over the root 3 over 2. It's only down a half. So it's over, positive, and down, negative, if you want to do the signs right in the triangle. So what is cosine is x, sine is y. So cosine is x. What is cosine? Root 3 over 2. Sine is minus a half. We know that also because of all students take calculus. Only cosine is positive in that quadrant, but sine is negative. Sure enough, sine is negative, cosine is positive. That minus sign came from the formula. right? We good there? So we get to here, and now, so 1 minus root 3 over 2 over negative a half. You guys good to there? Now, can you simplify that? Let me give you a second. It's really valuable that you could take that now and simplify it. What am I going to do to simplify that thing?
Take out the two negatives.
Oh, no. We can't take out those negatives. That's glue. Have I talked about Costco glue? Yeah, no. Right? These guys are what? They're stuck together, which means if you're thinking, hey, I want to come in here and and say, you're going to mess with me? You go like that, or you do nothing. Remember, I can't emphasize that enough. Pluses, I'll get to some of it. Hold on, let me be really clear on that. Plus and minus objects are all or nothing, right? Don't mess with part of them. Shopping at Costco, they'll put you in jail if you try to buy just one milk there. I assume. I don't know what they'll do. But they'll probably say something nice like, sir, we need you to buy both of them. I just want one. All right, anyway, sorry, I'm just being weird. So minus half, let me go back up here. So what do we do?
You gotta get rid of the 2.
Yeah, so guys, everybody see why this is a mess, because it's fractions over fractions, what we call complex fraction. What is the problem? The extra denominators, meaning him and him. If they weren't there, it wouldn't be a mess, right? If he was gone and he was gone, that'd be fine. Just leave it like that, right? Well, basically. Anyway, so they're the problem. Those 2's are the problem. So get rid of them. Multiply top and bottom by 2. I'm doing balance, same thing top and bottom. Cancel, right? So what do I get? 2 times 1, 2, minus, whoops, I already had the minus there. 2 minus root 3 over negative 1. Now, you can't leave a 1 at the bottom of a fraction. So what? What do you do? I'm going to sneeze, I guess not. I guess so. So take that minus 1 and put it underneath each one. Everybody good so far? So I took that minus 1, put it under the first one, put it under the second one. The subtraction is still in the middle. 2 over minus 1, minus 2, 2 negatives, positive root 3. There it is. Everybody okay with those last? I know it's all that little picky stuff that messes people up, so I want to go slow and be helpful with that and not just brush my hand and say, just do it. So I know that's where it gets people. Everybody see what I did there? So I got when you have fractions over fractions, you multiply top and bottom by the denominator, don't you? All the terms on the top, all the terms on the bottom by the denominator when you have fractions over fractions. Everybody see that? That'll come up a ton. Fractions over fractions, multiply top and bottom by it. Cancel. Get this, and now, sorry, I kind of worked left to right or right to left backwards. Then I had minus 1 at the bottom. We can't leave 1 in the bottom of a fraction, even a minus 1. So what do? Put it underneath both of them, and then this is negative 2. 2 negatives is positive root 3. Good? On that? All right. All right, let's do that one. Looks like it's easy enough. So try that one, sine theta over 2. So give it a try. Use the formula that I gave you last time. Or not last time, I'm going to give you a couple minutes ago. Use the formula for sine theta over 2 and plug stuff in. Right, so sine theta over 2 is something plus or minus square root of 1 minus cos theta over 2, like that. That good? Hey, is it plus or is it minus? Well, yeah, how do you know? Oh, that's good. That's good. They're all positive. Yeah, plus, this is a first quadrant triangle. Why do I know that? This angle must be less than 90 degrees. Why? How many degrees in any triangle? 180. 180 in any triangle. This right angle is already using up 90. There's only 90 left for the other two angles. So theta is less than, well, just look at it. It's clearly less than 90. How about that? I don't need to do all that fancy math. There's a 90. It's less. Right? That's less than 90, which means it's first quadrant. If you did the unit circle, it's somewhere in the first quadrant, isn't it? Theta is less than 90. So first quadrant, all the trig functions are positive. So whenever they give you an angle inside of a right triangle, you know everything's positive because that's less than 90. That's first quadrant. Right? Good on that? So just do the positive, the positive version alone. It's positive. 1 minus. Now, what's the cosine of theta? Whoops. How do I find the cosine of theta? Yeah, so katoa. So katoa. Cosine is adjacent, so that'd be adjacent over hypotenuse is opposite. So it's 4/5 over 2 like that. We good? Now can you simplify that thing? So I just got cosine's adjacent over hypotenuse. Use a little formula. Now simplify that. You can't leave fractions over fractions, right? So what do you do? What are you going to multiply by the 5, right? Because the 5 is the denominator. Everybody by 5. Is that good? So that's the square root of these cancel. 5 minus 4 over 10, which is the square root of 1/10. And, everybody good to there? So we cleaned it up. It's just a normal fraction now instead of fractions over fractions by multiplying top and bottom by the denominator. Now, we can't leave it this way because this means a root in the bottom. Remember, a root over the whole fraction means a root on the top and a root on the bottom. And in fact, I'll just write it that way for extra clarity. It means this, and you cannot leave a root in the bottom. Remember that? We can never leave a root in the bottom. So you know how to fix this from your algebra days. Just multiply top and bottom by root 10. So what do we get? Root 10 on bottom, root 10, root 10? Plane 10. So it's root 10 over plane 10. We good? Yeah.
Okay, I don't have a question on this one. I have a question
Ajane.
on 8, yeah.
Yeah. Number 8. Okay, sure. Everybody good with this one?
I said,
Yeah, Rudy.
if I was multiplying, if my denominator was a root 10 and my numerator was a root 2, and if I was multiplying the top,
So you had root 2 over root 10?
yeah.
And you're, okay, first thing, okay, let me make a couple comments, and I would reduce that to be root 1/5. You can go 2 into 10 right away, because they're both in roots. And now, if the 2 was outside and the 10 was in, no interaction, different worlds. But yeah, if they're both in roots, the first thing I would do would just be to make this root 1 over root 5. You can just divide them like you would any fraction, just reduce it like a normal fraction when they're both in the same world, and then multiply top and bottom by root 5. Okay, but having said that, let me answer your question specifically though too, because you still can't, you don't have to notice, that'd be easier. But if you don't notice that and you multiply top and bottom by root 10, that's what you were saying to me, right? That's okay, that's not wrong or anything. Well, let me show you what you would get. You would get root 20 in the top, just 2 times 10. The bottom, root 10, plane 10. Now, this needs to be reduced. How do you reduce root 20? Remember that from your algebra days? 4 times 5, 2. Or you can just go 4 times, how about just 4 times 5? Root 20 is root 4 root 5. And what's root 4? 2. See what happened there? So whenever you get something like a 20, you got in a root, you got to reduce it. So, right, because 20 is 4 times 5, the root of 4 is plane 2. And now,
2 goes into 10.
now 2 goes into 10, because now they're both at plane things, so root 5 over 5. You had a different problem on your particular one?
Yeah,
Yeah.
I had that one.
Right. Yeah, so that was a different problem than ours. He had different numbers. Kind of section that off. Okay, anyway, so back to number 8. Question on number 8 was there it is. Question on number 8.
Yeah,
Ajane.
so you know how it's -2 plus root 3?
-2, yeah, uh-huh.
Yeah, when did it get from like under the square root?
When did it get from under the square
Like,
root?
you know how it's like the square root of 1 minus cosine theta?
Oh, good question. That was the first version. I used one of the ones that didn't have that root. Get this out of the way, I'll show you. Yeah, I gave 3 versions originally, then I erased it. So maybe I kind of just raced ahead of you and you didn't see it erased. So originally it had this one, like you're saying, with had the root thing, you're totally right. And then it gave me two versions without a root. So make sure you have these in your notes. And you can always go back and look at the YouTube. But it gave me these. So there was three options for formulas. I could use this first one that has the root, or I could use this one, or I could use this one. I chose this one that does not have a root over the whole thing. I did that. Yeah, good. All right. All right, so they want the sine of alpha over 2. So I'm going to use the formula that we have been given, which is plus or minus the square root of 1 minus cos alpha over 2. Yeah, so there's the sine of alpha over 2 formula. So let's just start there. You know, when I don't know what to do, I just start with the formula at least. Just write down the formula. So, in fact, let me write it a little bigger down here. It's plus or minus square root of 1 minus cosine alpha over 2. Okay, so if that's for sine alpha over 2, there's the formula for it. Now, how do you do that? Well, I need the cosine of alpha, right? So the sine of the half angle formula is given to me in terms of the cosine of the regular angle. How am I going to do that? You could do the triangle thing, or you could use the special theorem, 1 plus tangent squared is secant squared. And that'll change directly from tangent to secant. Flip secant, you got cosine. I don't know if you're used to all those little formulas. Two ways to do it. Remember one of the original big formulas I gave you was 1 plus the tangent squared is the secant squared. So you could go 1 plus, this is tangent, right? 1 plus minus 5/12 squared is secant squared. So you could, here, I'll do it both ways. You could square that one. I'm going to do this quick, and then I'll do it with a triangle. So secant squared is 1 plus square the 12, square the 5 becomes positive 144 over 25. What do you do with the 1? What do we always do with the 1? Make it 25 over 25. Add them up. 169 over 25 is secant squared. Root it. That's 13 over 5 is secant. Cosine's upside down, 5/13. Cosine is 5/13. Except I've got to worry about the quadrant. What quadrant are they saying right here? That's quadrant 2, between 90 and 180, it's here, right? Alpha's in quadrant 2. So what? All students take calculus. Only sine is positive. That means cosine is actually negative 5/13. You might wonder, why do you have to add the sign there? Because when you root both sides right here, it should have been plus or minus. I should have been doing plus or minus from the moment you root. Do you guys know that from algebra? If you put a root over both sides, you have to put plus or minus. Do you know that rule? I don't like giving rules without reasons. X squared equals 9. Just think about that. You know how we solve it, right? We root it. But the answer is not just 3. 3 is not the only number squared that equals 9. Right? Go back to the original question. What else to the second power is 9? Positive or negative, huh? That proves that just rooting alone won't get you the whole truth, will it? Do you see that? See how that example proves it beyond a question of a doubt? Rooting alone will not get you the final answer. Plus or minus must be put when you root both sides. So right here, when I rooted, you have to do plus or minus. And then, but it's only one of the options. It depends which quadrant you're in. That's why I looked at, I'm in quadrant 2. Only sine is positive, so cosine is the negative option. Negative 5/13. So that's one way to find the cosine. Negative 5/13. Let me do the triangle way now, because that's what you're probably more used to. I assume you're not as used yet to all those little weird formulas. So let me just do the triangle thing. That's probably the best way for you to go. Just make a triangle. For what? Well, they told me tangent, so I'm just going to put a little triangle here. Make alpha, it's my angle. They told me tangent is minus 12/5. Remember SOHCAHTOA? So tangent is opposite over adjacent is hypotenuse, right? 5/12, tangent is 5/12. So 5. So everybody with me? I just did opposite over adjacent 5/12 because they told me, I've got so much scribbling all over this thing now. They told me, I'm going to erase this, that's okay. It's on the YouTube if you want to see it again later. But it doesn't matter. You don't have to do it that way. Tangent is 5/12. Don't worry about the negative. We'll do the signs later. So I did 5/12. What do you think the hypotenuse is? Good. Remember, 5/12, 13. They do it all the time. It's 13. You can do the Pythagorean. You'd find it. I'm just going to move on. Interest of time. So that's tangent. So, and what do I want? I want cosine. So what's the cosine? Adjacent over hypotenuse. Adjacent over hypotenuse. 12/13. But is it positive or negative? Well, it's actually second quadrant, even though I'm drawing a triangle in the first quadrant. It's really second quadrant. All students, only sine is positive, so cosine is negative. 12/13. Is that what we got a minute ago? I don't even remember now. It was 12/13, right?
What cosine was 5 over 13.
Uh-oh. I got a different answer? Did I get 5/13?
Tangent is opposite over adjacent. You did it backwards. You just flipped it.
Oh, thanks. Yeah, I better get it together here. Did I? Let me see. Tangent, let me write out tangent. Oh yeah, toe is opposite over adjacent. Thank you. So it should have been opposite, 12 and 5 there, huh? Thank you. Ben, is that everybody with me? I messed up. So opposite over adjacent. Opposite is 12. Adjacent should be 5. Thank you. It's still 13. All the rest to do. So cosine now being adjacent is 5/13. There we go. It's always good when you get the same answer 2 different ways instead of different answers. Something's not right. There we go. So having done all that, either way, by formulas or by triangle, you probably would prefer triangle. Just do the triangle thing. Find the cosine of alpha. Put it in right there. And so then what do we get? Plus or minus. I'll resolve the plus or minus thing in a minute. 1 minus, and what's the cosine of alpha? Minus, double negative there, 5/13 over 2. We good so far? Got to clean that up. Everybody see what I did? So using the triangle, started with tangent, found cosine, minus 5/13. Remember what quadrant we're in? Negative 5/13. Put it in right there for, whoops, why did I do that? Cosine alpha, right there. So double negative is positive. 1 plus 5/13 over 2, right? And now what do I can't leave fractions over fractions. So what are you going to do? Multiply by the denominator everywhere, top and bottom. Cancels right there. So plus or minus, I still got to resolve that. 13 plus 5 over 26. Everybody with me so far? This problem keeps, I've done this problem too many ways. I'm tired of it. All right, let's keep going. Let's wrap it up here. So coming up here, it's plus or minus the square root. What is that? 18 over 26. Plus or minus, divide by 2, 9/13. You with me? I just reduced that fraction, divide top and bottom by 2. 9/13. Can't leave a root in the bottom. Multiply top and bottom by root 13. This problem is never ending. So what is that? 90, 27, 117 over plane 13. Now, is it plus or is it minus?
Why didn't you square root that 9? Do 3.
Oh, you're right. You're right. Thank you, Wendy. You're totally right. I should make that plus or minus plane 3 over root 13 and then multiply top and bottom by root 13. Thank you. plus or minus 3 root 13 over plane 13. Much better. Thank you. Right, everybody see what happened there? Am I going too quick on all those little root steps? You guys doing okay? Am I losing you completely? So let me go back from the beginning. From the beginning, I wrote the formula 1 minus cosine alpha over 2, plus or minus, that's the formula. Found cosine alpha to be minus 5/13 from the little triangle. I made the little tangent triangle. Plugged it in, double negative, multiply by the denominator, 13 top and bottom, got to here, 13 and 5 is 18, reduce the fraction, 9/13, and then Wendy pointed out you can root 9. Just root it, plane 3, no more root on the top, right? When you root a number and it's rootable, then the root vanishes from that zone, right? So I rooted the 9, there's no more root on the top. But it's still there on the bottom because you can't root 13. It stays there. You with me? And then you got to get rid of the root from the top and bottoms. What did I just do? So you multiply top and bottom by root 3 here, 13, by root 13. And then I get to here. Now, is it plus or is it minus? That's the, suppose you're on Jeopardy here for the $100,000.
What is?
It's multiple choice. Be careful. It's a little subtle. What were we figuring out here in part A from the beginning? It wasn't sine alpha. Right? The final answer is whatever sine of alpha over 2 is. Half of alpha. What's alpha? Where's alpha? Between 90 and 180. So where's alpha over 2? Between 45 and 90. First quadrant, positive. Everything's positive in the first. Do you see that? Alpha is in the second, but alpha over 2 is in the first. A little trickery there. Do you see that? Because the original question here is what's the sign of alpha over 2? Alpha is in the second between 90 and 180. But alpha over 2, cut those in half, is between 45 and 90. That's the first quadrant. First quadrant. Alpha over 2. That's the real question. So in the end, positive. First quadrant. Good? Track with all that? So you've always got to remember, am I talking alpha right now or alpha over 2? Because you might think, well, wait a minute, Senator, right over here, you said that was negative 5/13 because cosine alpha, second quadrant. Right, because that was regular alpha. Everybody see the difference? That was cosine of regular alpha. Yeah, regular alpha is in the second quadrant. But the sign in the front has to do with the original question, which is alpha over 2, sine of alpha over 2. Alpha over 2, divide these both by 2, is between 45 and 90. First quadrant. Good? But you got it for the $100,000? All right. So I think I'm going to leave that. Oh, and then, well, they say part B. It's a long problem. Part B, cosine alpha, just going to be the same thing. Just use the formula. Yeah, that's exactly the same. And the tangent, yeah, I gave you the tangent formulas. So, yeah.
I just take a quick question.
Yeah, Rudy.
For the cosine alpha over 2, do we use the same formula, like the 1 root of 1 minus cosine alpha over 2?
So for the cosine, so for part B,
Yeah.
cosine alpha over 2, the formula is plus or minus the square root of 1 plus cosine regular alpha over 2. It's almost the same formula. It has a plus instead of a minus. Yeah, it's very similar to the sine one. The only difference between the sine of alpha over 2 and the cosine alpha over 2 is that sign in the middle. Did you guys notice that? It's the sign in the middle. That's the only difference, right? Look back over here. This looks the same, but it's got minus in the middle. The sine of alpha over 2 has the minus in the middle. Cosine has the plus in the middle. Everybody see the difference? So the rest would be the same. Square root. Oh, alpha over 2, again, that's first quadrant. So this is just going to be plus in the front, isn't it? 1 plus cosine alpha. What's cosine alpha? Well, we just found it back here. It's negative 5/13. So So it's going to be negative 5/13, like that. So that's the square root of 1 minus 5/13 over 2. Can I go dot, dot, dot? All the rest the same. Multiply top and bottom by 13 and blah, 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 blah. Right? On that. And then tangent, part C, that's part B. Part C, tangent alpha over 2. And I gave you 3 different formulas. I would use maybe the 1 minus cosine alpha over sine alpha version. And remember what cosine alpha, it's right here, minus 5/13 over. What's the sine of alpha? I don't know, you'd have to go back to that triangle. Remember the triangle we made? And we had alpha, and the tangent, which is opposite over adjacent, is 12/5, and this was 13. And so sine is opposite over hypotenuse. Sine would be 12/13. Is that good? Am I losing you on that? Is that making sense? So for part C, the tangent alpha over 2, there's 3 different formulas. This one's nice and easy to use. 1 minus the cosine over the sine. Oh, wait a minute. Yeah, is the sign positive? It is. Remember, this is regular alpha. Regular alpha is in the second quadrant. Second quadrant, all students. Yeah, sign is positive. Only in the second quadrant, yeah. So, is that good? Then this would be 1 plus 5/13. Multiply top and bottom by 13. I'm going to go dot, dot, dot. Okay, just that we're like 2 steps from the end there on that one. Is that good? Questions?